Hello, welcome back to our final session on pricing options using binomial trees in Excel. Before we stopped at our last session, we asked a very simple question. How does this sheet need to change if you were to price an American option versus a European option? The primary difference between an American option and a European option is that an American option can be exercised at any point in time, and a European option only factors in exercise at maturity. So what I've done is I've simply made a copy of my Efficient School 1 sheet and I've saved it as American call just so that we can save some time. And I'm now going to modify the sheet so that it can price the value of an American call option. The question that you have to ask yourself is how or what do we need to change? So if you go back to the definition, if an American call option can be exercised at any point in time, all you need to do is factor in the impact of the exercise. Let's pick any cell on the path of the tree on random. So let's say I pick this cell. If I'm standing at this point in time, now what is this point in time? This point in time corresponds to the state where the tree has the underlying priced at 122.29. So we're saying the underlying is at 122.29. At this point I have two choices. My first choice is if I exercise immediately right now, what will I get? If I exercise immediately right now at this point in time, I will get 22.29. Why? Because the underlying is worth 122.29. If I exercise immediately, I get the difference between ST, which is 122, and X, which is 100, which is 22.29. Right? This is what I would get if I were to exercise the option at this point in time immediately. I'm standing at this node, exercise immediately, get 22.29. But if I wait, what will I get? If I wait, there is a chance that I might go here or here, or I might go here and here, or I might go here and here, or here and here. So there are about four paths, right? This 26.21 is the expected present value of all of these four paths. I adjusted for probabilities and adjusted for discount factor. And this is obviously higher than the 22.29 that you have here. So if you were to apply the rule that works for an American option, that I can either exercise early or wait till maturity, if you were to compare the two results, you'll find that the option that allows you to wait till maturity is worth more than the option of early exercise. You can repeat the same calculation at this stage where we are, let's do this. So now at this stage we're saying early exercise would give us 30.78 because that's what you would get if you were to exercise immediately. If you were to wait, you would get 39.185, 39.85 or 22.29. And this 32.76 is the expected present value of the decision or the option to wait. So if I were to extend this, going back to our approach, I need to update this cell. And what do I update in the cell? I simply do a comparison. I say, look, the payoff at any given point in time for an American call option is the maximum of two values, maximum of early exercise. So this is what you would get if you were to exercise the option right now, immediately, or the option to wait. So D14 here, this cell gives me early exercise, this cell gives me the option to wait. I will simply pick the maximum of the two, the higher of the two values. And if I cut and paste this across the board, yeah, okay. So if I cut and paste this across the board, I have I've now updated the tree. If you look at the value, if you look at the comparison, right? If you look at the value of the tree, it's 11.79. If you compare this with Efficient School 1, it's also 11.79. So why no difference? Why no change? The reason why there is no change is for a non-dividend paying stock, it is not optimal for you to exercise a call option earlier. For a put option, it's a different story. For a put option, in certain parts, in certain areas, it is optimal for you to exercise early rather than for you to wait. So, so, so if I were to quickly review this, all we've done here is we've simply compared the benefit of early exercise with the payoff. So the benefit of early exercise, if I would now trace this, you'll see that the early exercise now simply says, if I wait, I get 32.76. If I exercise now, I get 30.78. Similarly here, if I wait, I get 26.21 versus 22.29. If I wait here, I get 14 or 20.48. If I wait here, I get 15 or 6.94. And if I wait here, I get 0 or 11.79. Even lower ends of the tree, if you come at this point in time, if you exercise now, you get nothing because you are below the strike price. However, if you wait, there is a small chance that you might actually end up in this state. And if you end up in this state, the expected present value adjusted for probability and discount factor of waiting at this point in time is 1.66. So now let's repeat this calculation and repeat this exercise. Now that we've done this, let's repeat this exercise for a put option. So I'm simply going to go ahead, move and copy this and create a separate sheet for pricing in American put option. Let's update this into a put. Now if I do a put, let's remove all the arrows. If I do a put, remember all we needed to do previously was to update the payoff profile. So the payoff profile now becomes max of X, which is the strike here. The payoff profile here becomes max of X. X is the strike, lock it, F4 minus ST, comma 0. That's the payoff profile for a put option. Now if you trace this all the way down, the value of the put option, the value of the American put option is 3.08, and if you compare this with the value of a put option for a European call, that value is 2.27. So the American put option is more valuable than an American call than a European put option, and this result is different from the result that we saw earlier for the difference between a European call option and American call option, which was the same 11.79 for a European call, for an American call, and 11.79 for a European call. Here we're saying, look, American put is 3.08, European put is 2.27. So why is that? Let's see what the tree tells us. If I were to trace the path of the tree, let's do trace. So this path we understand. It's better for you to wait. Are there any instances where it is beneficial for you to actually exercise early rather than wait? So let's see. Exercise early 12.56, 18.23, 23.53, and so now if you see, you can see that if I were to compare, if I were to, let's see, simply see, so if I look at this cell where I say 23.53, I'm saying, look, if I compare the two values, in this specific case, it's beneficial for me to exercise early at this point in time rather than wait. Similarly, here also, it's beneficial for me to exercise early rather than wait, beneficial for me to exercise early rather than wait, beneficial for me to exercise early rather than wait. Right? And why is that? So if I were to compare the values, if I were to simply do fx, I'm saying that if I wait, it's only worth 21.554. If I exercise now, I get 23.53. So it is beneficial for me to exercise early rather than exercise late as far as this specific tree is concerned. So quick review. What we've done is we've gone out and updated our spreadsheet so that it can now work equally well for a European call option as well as an American call option, for a European put option as well as an American put option. One of the lessons that's come out of this is that we've seen that it's not optimal for us to exercise an American call early whereas it may be optimal for us to exercise a European put early. So for vanilla calls and puts, whether American or European, this sheet works fine. How or why or where would you start if you were to price exotic option? Something like let's say a knock-in or a knockout, up and in or an up and out option, or a sudden death option, or an option that is also known as a path dependent option. Right? Now, for a path dependent option, just like an American option, you have to add a conditional calculation in the tree. And what would that conditional calculation be? That conditional calculation would simply be, if you look at what is a knock-in or a knockout is an option that is dependent on the path that's followed. You can define a set barrier. As long as prices stay above or below that barrier, the option behaves in a certain fashion. The minute they cross that barrier, they behave in a different fashion. So example, if I have a knock-in option, let's say that's set at a barrier of 130, it will only come into existence if the price part touches 130. Before or below 130, it will not exist. Similarly, if I have a knockout option, up and out option, in this case, same barrier of 130, this option will exist as long as prices stay beneath 130 and will cease to exist, will simply get knocked out or will die or disappear if prices touch 130. So let's take a look at a quick sheet or a quick example where we extend our efficient school 1 for pricing a European, let me see, pricing a up and out option. And I'm going to simply name this sheet, that's efficient school 1, simply going to name this sheet as a up and out. So if I take an up and out sheet, what do we need to change? For an up and out sheet, we still back to a normal sheet. For an up and out sheet, the test that you want to apply is that, look, this, let's introduce a barrier of 131, right? Let's make it 132. So if I introduce a barrier of 132, an up and out sheet needs to test for two conditions. The first is, well, this payoff is only going to happen if we're doing up and out, is only going to happen if this ST, if ST here is less than the barrier. And let's lock the barrier. So I'm saying if ST is less than the barrier, you will get something. If ST is not less than the barrier, then you simply get 0. Right? And there we go. So because you've touched the barrier, the payoff is simply 0. And let's bring this down all the way here. So because our barrier is specified and struck at 132, you can see that this payoff works. If I bring this down to 130, if I bring this down to 120, if I bring this down to 115, no difference. If I bring it down to 114, right? So you can now clearly see that the value of the tree is dependent on the barrier being hit or not. Let's bring this back to 131. That's the first part. So we sort of struck the payoff, updated the payoff for this calculation. Now the second part, you also have to apply this test on these values, because what you're saying is if the barrier has been struck, then I'll get a payoff. If the barrier has not been struck, then I will not get anything at all. So if I now update this tree, so it's at 8.10. If I now update this tree, let's say if ST, this cell here, F4 lock, is less than the barrier, then you get this, otherwise you get 0. Right? So that's the second condition. And if I now apply the second condition across the board, undo. If I apply this condition across the board from here to here, so I haven't locked it. So all I need to do is lock it before I do this. Lock it. There we go.